In the first problem, we are given 2 points. Their coordinates are given. This is just a sketch. And there's a line that joins these 2 points. And this line is going to be the diameter of a circle. And we're asked to find the equation of the circle and write it in the standard form. Now, in order to write the standard form equation of a circle, we need to know first the center of the circle and also the radius of the circle. If the center of the circle is given by coordinates hk and the radius of the circle is r, then the standard form is written this way: x minus h squared plus y minus k squared equals to r squared. So how do we get the center and the radius from the given information? Because this line is a diameter, therefore the center, the midpoint of this line must be the center of the circle, and half of the diameter, which is half of the distance between these 2 points, must be the radius. Therefore, we need to first use the distance formula to determine the distance between these 2 points, and then use the midpoint formula to determine the midpoint of this line segment joining these 2 points. So distance formula equals to x2 minus x1 squared plus y2 minus y1 squared. So in this case, 4 minus negative 3 squared plus negative 2 minus 7 squared. 4 minus negative 3 is 7. 7 squared is 49. Negative 2 minus 9 minus 7 is negative 9. Negative 9 squared is 81. And that equals to square root of 130. Okay. And then we need to determine the midpoint of this line segment, and the midpoint is given by the midpoint formula: xm ym equals to x1 plus x2 over 2, and then y1 plus y2 over 2, which is negative 3 plus 4 over 2, and then 7 plus negative 2, which is minus 2 over 2, and that equals to 1/2, and then 5 over 2. And this is HK, which is the center of the circle. And this D right here is the diameter, therefore the radius equals to half of that. With that known, now we can write the equation for the circle, which is x minus h squared plus y minus k squared, that equals to r squared. So 130 square root over 2 squared, and that equals to 130 over 4. If you want to continue to simplify that into 65 over 2, that is fine too. Either way, this is the equation for the circle. In the second problem, we're asked to write the equation of another line in the slope-intercept form that is perpendicular to a given line, 4x plus 2y equals to 5, and also has the same y-intercept as this given line. In order to write the line that is perpendicular to this line, we need to first know the slope of this line, and also because we need to find the y-intercept of this given line as well. So the first step will be to write this given line in the standard slope-intercept form. Okay. To do that, we know the slope-intercept form looks like this: y equals to mx plus b, with m being the slope and b being the y-intercept. Therefore, in order to rewrite this equation, we need to isolate y and leave it on the left-hand side. Therefore, we move x to the right-hand side, negative 4x plus 5, and then the whole equation divided by 2, y equals to negative 2x plus 5 over 2. Therefore, m1, which is the slope of the given line, is -2, and the y-intercept is 0, 5/2. Now, to write the equation of the new line, which is perpendicular to this first line, we know that for two lines to be perpendicular to each other, their slopes must satisfy that the product equals to -1. In other words, m2 equals -1/m1, which equals to -1/2. Therefore, this equals to +1/2. Okay. So now we're looking for a line that has a slope of 1/2, and it passes this point 0, 5/2. So we can apply the slope point method to write this line. So y minus y1 equals to m times x minus x2. Plug that in. So y minus 5/2 equals to 1/2 times x minus 0, which simply equals to 1/2 x. Therefore, y equals to 1/2 x plus 5/2. So if you say, since I already know the new slope and also I already know the y-intercept, can I just apply the slope-intercept form directly and write this equation directly? Yes, of course you can, but I was using this opportunity to review this point slope method, so that what if you are asked to write an equation that goes through a different point, say the x-intercept or just some arbitrary point, you should still be able to solve this problem. In this third problem, you are asked to evaluate the function at 3 different values. This function is a piecewise function, which means that it is defined by more than one equation. In this case, it is defined by 3 equations, depending on what region your x value, your independent variable, falls into. So the first is when x is smaller than or equals to -4, and then the second region applies when x is between -4 and 0. X could equal to 0 as well. And lastly, when x is bigger than 0. So let's look at these 3 problems respectively. Part A, evaluate the function at x equals to -4. And when we look back on this function, we realize that x falls into this region. Therefore, this first equation applies. This is simply a constant function, and it doesn't matter what x is, the function value is always 0. Therefore, the answer for the first problem is 0. B, evaluate f0. When x equals to 0, again, when we examine the functions, we realize that the second equation applies. To evaluate that, we understand that x is like a placeholder in a function. Therefore, we need to replace all the x with its value. In this case, we need to replace this x right here with 0, and that equals to 2 minus 0, which is simply 2. Lastly, we need to evaluate when x equals to s squared plus 1. Now, this problem is a little bit trickier because you are not given directly what this x value is. However, because we know that s is a real number, therefore, for any real number, s squared must be non-negative. In other words, s squared must be bigger or equals to 0. Therefore, s squared plus 1 can only be bigger than 0. It must be a positive value. Based on that, we know that we need to choose the third equation because that equation applies when x is bigger than 0. And again, x is a placeholder. We need to replace x by its value. In this case, s squared plus 1 plus another 2. So the answer is s squared plus 3.